there is a lot of water in our atmosphere. I went to a few websites. I just did a Google how much water is in the atmosphere, and this is the USGS website, usgs.gov, Science for a Changing World. The USGS Water Science School talks about there is always water in the atmosphere. Clouds are, of course, the most visible manifestation of atmospheric water, but even clean air contains water in particles that are too small to be seen. One estimate of the volume of water in the atmosphere at any one time is about 3,100 cubic miles, or 12,900 cubic kilometers. And it goes on to say that if all the water that's in the atmosphere were to rain down at once, it would cover the globe to a depth of about 1 inch. And this is confirmed on a number of websites, but I'll just show you one more just for the sake of argument here. This is the Y Files, the science behind the news. They have an article, How Much Water is in the Atmosphere? It says, at any moment, the atmosphere contains an astounding 37.5 million billion gallons of water in the invisible vapor phase. This is enough water to cover the entire Earth, land and ocean, with 1 inch of rain. And of course goes on to talk about that as well. So, yeah, there's a lot of water in the atmosphere. I think we all kind of just know that, but I don't think we've ever really thought about what that means. And so I'm thinking, if the atmosphere, especially over water, is made up of zillions and zillions of tiny convex drops of water, then collectively perhaps they all combine to make one big convex lens, in which case it would act like a magnifying glass. Okay, so with that in mind, let's look up some websites dealing with the refraction of light. You might see a graphic, something like this, showing light bending downward. And here's your typical graphic showing how light rays entering some sort of medium, like in this case water, refraction causes the light to bend downward. Now, we've all seen pictures of, a pencil or something in a glass of water, and how not only does refraction bend the image downward, it also magnifies it. I'm going to say that again. Water causes refraction, bending the image downward, and magnifies it. So this is important now. So now back to another clip from that previous video.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here, now you can just see the top of the Sears Tower, and if our simulated temperature inversion moves into place, hopefully now you can see pretty much all of Chicago,
see all the lower buildings,
including what's at ground level.
So the atmosphere really is acting like a lens.
Yes.
The science is the same of that of a lens. Here's a simple example.
The atmosphere really is acting like a lens.
Yes.
Hey guys, Rob Skiba here with another testingtheglobe.com short video. So, if you've been following some of my other videos, I've been showing how I believe the sun and moon work over the flat Earth model, and taking advantage of the fact that the atmosphere is full of moisture and that it is acting like a lens. I've done a number of videos, and one of the questions that has come up a number of times actually is, how is it that the clouds can be lit from underneath? Now, in the spinning heliocentric globe model, it's essentially explained that as the Earth is rolling away from the sun, as it's spinning, it rolls such that the sun is at a much lower angle, and because of that angle, the sun is shining up, and the sun rays are hitting the bottom of the clouds. So when you show people the model of the sun going around in a parallel path above the circle of the Earth, they say, well, you know, in that situation, the sun is above the clouds, and so how could it possibly illuminate the bottom of the clouds when it's doing that? So I decided to take up that challenge and see if I could figure that out based on what I had learned in my previous experiments. And so I got one of these stick 'em up LED lights. You know, you kind of push the button, it's got 3 little LED lights inside. And I taped it up so only one of the LED lights is showing, and stuck it on a box and put it on the table with my trusty plastic lens set up here. And I took my stand that I was using for the sun and moon and just set it up right here on top of these little Tupperware things. And I was thinking, okay, so that's, let's just say the bottom of this little stand here represents the bottom of the clouds. And so as you can see here, the light is way above, you know, it's well above what would be the bottom of the clouds in this example. So let's see what happens. I turned off the lights and set my iPhone to record, and I'm showing myself here recording all of this with another camera, and I pulled the light back on the table, and watch what happens here. Ooh, check it out. And there's that refraction taking place again. It's got the light. It made the sun set, first of all, below the horizon in this case. And let's just show, this is just the iPhone view. I'm going to bring the cloud in here, and the platform represents the bottom of the clouds. So the sun's going down, and oop, there it is. The bottom of the clouds illuminated by a light source that's well above the clouds, moving parallel over a flat surface. So apparently it's possible for the sun to illuminate the bottom of the clouds even on the flat Earth model. Thanks so much for watching. I hope you